Alright, welcome to this quick update video. What I want to do in this video is give you an update on where I am in terms of the development of the StructureWorks add-on, and also update you on the timeline for release of the add-on, but also release of the course, the associated course. It's going to show you how to build version 1 of this add-on and just add-ons in general in Blender. Okay, so the first video that I released on this topic was back in August, and that's where I introduced the idea of building an add-on for Blender. And I also wanted to determine whether or not there was an appetite for one structural analysis add-on for Blender, but also a course on how to build add-ons. Basically, the ability to build add-ons in Blender offers some really big advantages because you can essentially build your own tools to help speed up your own workflows in Blender. So I'm pleased to say that there was a really good response to that video, and a lot of people wanted an add-on for structural analysis in Blender, and also wanted to know how the hell you build it. So I decided to go ahead and continue working on it. Now, between then and now, there was another course released on engineering skills on structural safety and reliability. So that was published. I got that out the door in the end of November, and so since the start of December, I've been back working on this add-on. And so I thought, in this sort of quiet period, as I'm recording this just before Christmas, it was a good idea to update you on progress, what I've managed to get done in the last couple of weeks, and what is left to do before you're going to see the add-on out released, and before I start releasing lectures on how to build it. Okay, so let's just jump over into Blender, and I can kind of demo the workflow here. So you'll remember from the last video, if you saw it, I showed this structure, this very simple truss, space frame truss structure. What I'll do here is just run through the analysis of this again, and that will help highlight what's changed in the add-on. So once you've installed the add-on, you can bring it up or reveal it by hitting N and bringing up your N panel, and it'll appear here if you've installed it. It's StructureWorks is the name of it. So just like before, the first thing that we have to do is select the object that we want to analyze. Now I have a few objects. I've only got one visible, so we've got this truss structure is the only visible object in the scene. So I'm going to select that as the structure that I'm going to perform my structural analysis on. Now the very first thing that we can do that's different is we can toggle on node numbers and member numbers. So this is quite helpful. It's a simple thing, but I have lost track of the amount of time that I've spent in Blender trying to, if we just collapse that a second, trying to read these little blue index numbers. So if I come in here, if I come into the mesh edit mode overlays and turn on indices, you can see, if you look really closely, well, they don't actually scale with zooming, but you can see there's little blue numbers that give you your node numbers, and they're really bloody hard to read. And so the first thing that I've done here since I started working on this again is add in my own node numbers. So we can just let's just turn off those blue numbers for a second. And we will bring back up the structure panel. Because we're in edit mode, we saw this before, we can see all of the nodal coordinates and all of the member definitions. So we'll collapse, let me see, we won't collapse it. We will come out of edit mode and we will hit this button, and we can see now we have our node numbers are a bit easier to see, and we can manually scale those. There's a little slider. If I come down into my visibility UI section, we can increase the text size of those to make them a little bit easier to see depending on what we need. And we've got the same thing for member numbers. So again, just a very small addition, but a good example of when you can build your own add-ons. If you see something that you don't like in Blender that's bugging you for your particular workflow, well then just change it. Alright, so next up was materials. No change to materials yet. So again, to analyze this structure, I'll just go ahead and assign some materials. So tabbing into edit mode, going into edge select, I will assign everything, collapse down that, I'll assign everything steel, so I'll just hit assign on that, collapse that down, and then we'll assign some sections. Again, there's nothing new with sections other than to say that we can turn on the section number identifier as a little label. We can do the same for materials, material number as well. Now we can see that in sections, because I haven't assigned any sections yet, we can see that it says section 0, which is telling us that there's no sections assigned. So what I want to do is I want to assign this beam section to all of my elements. Let me just turn those off for a second. So when everything's selected and the beam selected in the list here, I'll click assign. Again, this isn't different. We had this back in August. If I turn on my section numbers now, section ID numbers, we can see they're all section 2. Okay, so moving right on down, restraints. So what I have done is I've added the ability to see the restraints in the 3D viewport. So if I tab into edit mode and go into node select mode, if I wanted to make that and that and that and that, if I want to pin those, I can pin them exactly as I did previously by setting UX, UI and UZ to be restrained. And when I add those restraints, we can see now that we have some models in the 3D view that are going to show the restraint. And if that's not big enough, we could scale it up as well. So we can have a manual scale factor here. So I can scale those up or scale them back down to make them easier to read. And the restraints are shown here, and this is live. So if I, for example, if I want to change the level of restraint on node 24, if I just see which one is node 24, that's going to be this guy down in this corner here. So I can change the level of restraint by directly editing what's in this table. So I can change that back to 0 and we lose our level of restraint in the X direction. Let's turn it back on again. Alright then, forces as well, not a huge amount new here except for that I've added some 3D models so that we can see the applied forces, which is really handy. So if I come back into edit mode and I just select add some forces arbitrarily to this structure here, we'll assign 5,000 newtons in the negative Z direction to the selected nodes. So I'll just hit add selected and we can see our forces are applied, and we can do the same thing. I just want to add some horizontal forces to these nodes here. Let's add, let me see, what do I want? I don't want 5,000, I want, let me see, let's go with 2,000 in the X direction. And we want to add selected, and there we have it. So we've got our force arrows added, and there's a relative scale between the two. So we get a sense of which are the larger forces and which are the smaller forces. Okay, so we've got forces applied, we've restraints, we've added sections and materials. We're saying we also want to include self weight, and we've specified the direction for self weight is the negative Z direction. Now at this point we can export the model data, and we saw how we did this previously. We can just hit export here, and that will send the all of the data that defines this structure and its loading. It'll send that to a CSV file called model data, and it'll send it wherever I want to send it. So last time we did the analysis externally, and I suppose the big difference now is that we can do all of the analysis internally within Blender, so we don't need to send out to an external file. Now when I release the course, all of the external analysis files will be included as well, but the idea here mainly is to get to a situation where we're doing all of the analysis internally within Blender. So the external analysis, and let's just bring it up here. So this was the notebook that we showed in the previous video. So if I just run this notebook now, it will analyze the structure that is defined in the CSV file that we just exported. So we'll just run that. Alright, so there we have it. So the thing runs, and again, we saw this already. So we've got our structure here, and we've got some nice plotting in matplotlib, so we can show the nodes. The colors are indicating whether it's a forced node or a restrained node, and we can show the forces, scale those up. So yeah, so fairly straightforward. Coming on down, the material or the element color here is being dictated by the material color in Blender. So if I come back in here, we said everything was steel. Steel is given a color red, and so over in our plotting here, we've got red elements. Coming on down, we've got our deflected shape. Let's let me see. Let's scale that manually by 100. Something a bit more realistic. Coming on down again, we have our axial force diagram. Again, we saw all of this before, but the nice thing now is instead of doing the analysis externally, or in addition to doing it externally, because I still think that's a handy thing to be able to do, and we can do the analysis internally within Blender. So externally, we just run some OpenSees code, and that will analyze the structure. But internally in Blender, it's really tricky to get libraries. Any library that doesn't come bundled with Blender, it's kind of tricky to get it running in Blender. And plus, there's a complication around distributing OpenSees in that way. And so I just went and wrote the code to do the analysis. And of course, it's the code that you will have learned or you will have used in the space frame analysis course on engineering skills. It's the exact same code. So if I come on down, just collapse that and come down to analysis, we can set a 2D truss analysis or a 3D truss analysis. Now clearly it's a 3D truss that we're dealing with here. We can just hit analyze structure. The analysis is complete, and now we have all of our results. So we've got our nodal displacements, we have our internal member forces for each element, and then we have our support reactions. And of course there's labels to go with all of these. So we could get our nodal displacement labels and zoom in and basically see what is our nodal displacement, and we can do the same thing for our member forces and our reaction forces down here. So we're doing all of the analysis for this space frame internally within Blender, which is really nice. There's no need to go out to an external notebook and then import results back in again. And then the other thing we can do is look at our deflected shape. So if I come on to here, we can say we want to see the deflected shape. And so we can scale that deflected shape. So let me see, let's start off with 50. Okay, and we can basically get a sense of how the structure is deflecting. And so we can again scale that up and down to see what way the structure is deflecting. So really that's all of the results. Now the only thing that's missing here that I haven't implemented yet is a nice way of visualizing the axial forces. What we ultimately want to do is get to a point where we have something like this in Blender. And of course we did do that at the end of the 3D space frame course, and we went through some code in Blender. We wrote some scripts in Blender to build a heat map like this over in Blender. And so what I need to do now over the next couple of weeks is just implement that within this add-on, so that we'll click another button here and we will see a mesh representation of each of the individual elements, and we'll color those elements based on the axial force in the element. So that's kind of the next big thing that I have to do. And once that's done, we're nearly there. So we've got to build that mesh representation, build the axial force visualization. I also want to build a better way of visualizing each element by the section that is assigned to that element, and also by the material that is assigned to the element. And what I'll probably do is color the elements, have an option to color those elements based on the material color, which is specified in the materials table. And I'll do something similar for the sections, so that very, very quickly you'll be able to see which elements within your structure are using which material and which section. Okay, so let me see, is there anything else to flag up at this stage? We have a pie menu, so it's kind of handy to be able to access all of your visualization controls. If I just collapse the results down, to visualize all of your UI visualization controls in one spot. So we have them all here, so we can toggle on everything here. We can turn off that deflected shape, turn it back on. We can scale it up and down from here. We can, let's turn it off for clarity here. We can turn on node numbers, element numbers, material IDs, section IDs. We can turn on and off the restraint visualization. We can turn on and off the force arrows. We can turn on and off the force labels. You see where I'm going with this? Nodal displacements, member forces, reaction forces. Okay, so we can do all that there, but we can also bring up a pie menu, which allows us to access it all really quickly. So currently that's Alt W, and we can bring up all of the visualization controls from here. And that's, to be honest, in using this add-on as I'm developing it, that's what I'm finding I'm using most often. I'm not really coming over here and doing much here. I'm really just jumping in here with this pie menu. So that'll probably undergo a little bit of further development as well. One thing to say as well is we can change the text label size. So if I turn on nodal displacements and we think that's a little bit too big, we can bring those down or bring them up depending on what level of zoom or what way you're looking at it. So that is pretty much the state of play at the minute. In terms of timelines, the objective really is to get V1 of this add-on to a state where I can release it by the end of January. I'm aiming for, depending on how much work I can get done over this sort of Christmas New Year break. When that's done, when V1 is out, then I will start producing and releasing in blocks the lectures for the course that is going to show you how to build V1 of this. So V1 will be the version of the add-on where you can, where you can do 2D truss analysis and 3D truss analysis. So that's the idea. Now, we're going to focus on building that in the course. Now, once you've worked through that course and built V1 of this add-on, you don't need to watch more videos of me building additional features into this add-on. You'll know plenty to go and, build your own version or extend it or do whatever you want. You'll have enough covered. So there's no point in me doing much more than V1 or covering much more than V1 of the add-on in the course. Now, so that's the course. Separate to that is I'm going to continue working on this add-on because I sort of like the idea of building this out into a fully featured analysis add-on where we look at V2 of the add-on. We'll probably have 2D beam and frame analysis, maybe 3D beam and frame analysis, because we've written all of the code to do all of these things anyway. It's all covered in various engineering skills courses, so really all I'm doing is taking the code from those courses and, with a few little tweaks here and there, bringing it in and incorporating it into the add-on. So I can sort of see a long-ish development roadmap for this add-on, depending on if people like it and people use it, of course. So that's the idea. So sure, listen, while we're here, why don't I just do one other quick analysis? You've basically now, you understand the timeline, you understand where we are in terms of development. The meat of the video is done. But while you're here, if you're interested, I'll just run through the analysis of a slightly bigger structure, just again to demo where we are with this add-on. So what I'm going to do is just collapse everything down. I need a button here. That's one of the things I need to do, is add a button that allows me to collapse all these in one go. So I'm going to come in and I'm going to get rid of that, and I'm going to hide that structure. I'm not interested in that structure anymore. And what I want to do, the roof, we looked at that in the last video, so I'm not going to look at that again. So I was having a play around and came up with this structure, which is just sort of a simplified tower crane structure. So again, something like this is why I like using Blender, because it allows you to pull together structural models like incredibly quickly. Once you get proficient with Blender, which you get 90% of the way there within an hour or two, in terms of just modeling, that is. It's really handy. It's a really handy tool. So anyway, look here's our tower crane. So I'm going to select that. I'll run through this pretty quickly. So I'm selecting that crane. We've got again our node numbers, member numbers, all that we've seen. Let's come on down. Materials. Everything here is going to be steel. So I'm tapping into edit mode, edge select mode, selecting everything and assigning steel. Coming on down then, sections. I'll assign everything to beams, and then so beams is actually got this cross section area 0.01 meters. Then these guys, let's make these a larger cross section, so they're going to be beam 2, which is 0.05. Let's assign that. Let me see. Okay, so they're all section 3 and everything else is section 2. That's fine, so we can collapse that. Let's just turn off those section labels. We don't need nodal displacements because we haven't calculated them yet. Okay, so there we have sections done. Restraints, let's come on down to the bottom here. We'll go into nodal select, select those guys, and we will UX, UI, UZ, add selected. That's fine. All right, in terms of loading, come on down. Well, we want gravity self-weight loading. It's acting in the negative Z direction. That's fine. Let's just add some loads to the very tip of this crane in not the X direction, but in the negative Z direction. So let's go with minus, doesn't really matter, it's just for demo purposes, minus 2000, and we'll add those. Okay, great. So there we have it. We've got our forces, we've got our restraints. Let's collapse that guy down. We will export this data because I'll run it over in the Jupyter notebook as well. So I'll just hit export, that's fine. And then come down to hit analysis. We'll analyze the structure and we're done. All right, so we have tables of results here. Now, I could export those results as well, by the way. I did not know I said that. So we can send those to a CSV file called results data. Might as well do that. So that's out there in case you want to do something else with them or import them somewhere else. And now let's just have a quick look at this. Let's bring in our orthogonal views here. So what do we want to do? Well, we really want to see the deflected shape. So deflected shape, okay, that's crazy. Let's bring that back down to 1. Scale that back down to 1. All right, there we go. So again, we've got a nice visual representation of the deflected shape. I can come in here and I can sort of slide that scale backwards and forwards to get a sense of what this structure is doing or wants to do underneath those loads. All right, and so you can imagine in the next video you see, the next update video, when I have a nice visual representation of the axial forces, that's going to complete the picture quite nicely for this particular structure. So there you have it. That's the state of play. Hey, Sean from the future here. While editing that video, I realized that I never actually ran that model, that crane model, over in our Jupyter notebook. For completeness, I just wanted to show you that before we wrapped up the video. So heading over to the Jupyter notebook, when we run that file, we get this guy here. So we have, again, our model, our deflected shape with some arbitrary scale applied to it, and our axial forces. And again, this all intuitively makes sense to us when we look at the concentrations of both tension and compression forces. So again, yeah, just to sort of complete the picture. Again, these notebooks, these external analysis notebooks that are written using OpenSees, these will be distributed as part of the course when it starts being released at the end of January. Okay, that's enough from me. Back over to the main video. The idea is to get this out the door by the end of January with a little bit of luck, and to, as I say, start releasing the videos for the course so that you can build your version of this and, you know, any other variations of it. Again, very shortly thereafter. So again, late January, early February. And the plan, I think, because I don't know, but I'm imagining it's going to be quite a long course. There's a lot, like it takes a lot to build this. It's not complicated, but there's just a lot of work to do. So it could be a relatively long course. And so what I'll probably do is release those course videos in sections, so like in batches. Okay, so that's the plan. So hopefully you found that interesting. If you've got any feedback for me, you can leave it. If you're watching this on YouTube, you could leave it in the YouTube comments, or you could head over, if you're a member, an engineering skills member, you can head over to the community forum. There'll be a discussion thread there, and do please feel free to leave any comments or suggestions that you have for this add-on. Leave them there. So people have been leaving comments there and they've been quite helpful for me, so I'll be sure to read and reply to anything over there. I don't know whether I've said it yet, but lifetime members will get access to the add-on and all future updates of the add-on as part of your lifetime access to everything on engineering skills. Annual members will get access to everything and all updates as long as you have an active annual subscription. And then of course there'll be the option to purchase the add-on and purchase the course, or both of them together. All right, so I hope you found that interesting. I'm knocking off now for Christmas, so I will talk to you again in early January. All the best.